H reporting no symptoms. Okay, now how did I get that? I got that from the story. Okay, so for example, over here, it says, both groups were told to take the drug. 30 patients in group A reported having no more symptoms. So they're measuring the number of symptoms, the people that had reported not having any symptoms. Okay, so we have two groups, of course. So we have group here, group A and group B. Oh. Group A and group B. And we had 3 trials. 1, 2, and 3. And in the first group here, it says trial 1. Let's see where trial 1 is. Let me see if I can move this thing out of the way here. Trial 1, 30 patients in group A reported having no more symptoms. So 30, oops, sorry. Trial 1, 30 in group A, 30 said they didn't have symptoms. And in group B, in that same trial, 10 in B said that they didn't have any symptoms. Okay, that's why we give the placebos. The placebos are sugar pills, and some people, if you just tell them that they have a medication, that they're giving medication for the disease, they'll automatically, subconsciously, their bodies will start thinking and believing that they are better. And so some people, it works that way. So we just want to make sure that it's just that particular thing that's causing the change, which is that medication, the Kudikilla. Okay, so for trial 2, we have 25 patients, okay, that said they didn't have any symptoms in A, and we had 8 people in group B that said they didn't have any symptoms. And then in trial 3, we had 28 in group A that said they felt great, and 10 over here in group B that said that they felt great. Okay, so this is how we do our table there. We have a little title showing what is being measured. Okay, and then for a let me see here. And by the way, that wasn't letter B, it was H. Sorry, I'm missing handwriting. H. Now I, it asks us, in I, it asks us what type of graph would be used for this data. Okay, so type of graph, there are basically 3 types. There's a line, a bar, and a circle. Circle only shows us a percentage of a whole, which is not what we're measuring here. We're just comparing 2 groups and their symptoms. Okay, so a circle graph would not work. Now a line graph, line shows us the trend with time. And in that one, you can actually have things compared. Okay, so you can be comparing different things. And a bar graph is just basically for comparing, whether it's in an instance or through time, either one. Now, because these 2 actually are appropriate, you could put either one and I would accept it. Okay, so the appropriate ones would be line or bar. Both of them are based on that table. We can say hypothesis is correct. People taking oops, didn't quite come out right. People taking the Kudikilla were 3 times more likely to have no symptoms or cured. Yeah, because we have to measure how they're getting cured, so it's by the symptoms that they have. Sorry, there's a misspelling here. Okay. Now, how did we get that information? How did we come up with that? Well, if we look at the data here, if we look in here, 3 there were 30 and there were 10 here. 30 said that they were better and 10 said that they were better than B. So that means that there were 3 times more people getting better with the treatment. Okay? So then over here, we look at 25 through 8. 8 and 2, 25 will be about 3. 8 times 3 is 24. You get a remainder, we're going around. That's still 3 times more likely to have less symptoms if they took the medication. And then if we looked at the third trial and analyze this, we see that it's, let's see, it's about 10, 20 into 10 is about 2.8. We round to 3. It's still about 3 times better. People that took the medication were 3 times more likely to have less symptoms or no symptoms than the people that didn't take the medication. So that's why our inference, and when we do inference, we look at data and we come up with a statement based on the trend or the pattern that we see. So the pattern that we see here is that there was 3 times more likely people to get better using the treatment than not using it. So that's why we came up with our inference. Inference, again, use your data to derive a conclusion based on the data. All right, so now K, in K it asks us whether this was a valid experiment. And the way that we know if something is a valid or controlled experiment, okay, is that there has to be certain components present. Okay, so for K, okay, for an experiment to be considered scientific or valid, okay, it has to be a controlled experiment. It has to be controlled experiment. And controlled experiments have 3 components, or several components, but we're going to cover some here. 1, they have to have trials, at least 3 or more. Okay, let's see. Tries at least 3 or more. Still doesn't do it. Okay, well, I tried. Okay, 2, it has to have 1 independent variable and 1 dependent variable. We keep it simple. We only test one thing at a time. Okay, then it also has to have a control group and an experimental group. Oh, cheese and crackers. Okay, let me do the other one. Okay, we're just gonna have to undo the whole thing. Sorry, because I have really bad handwriting. I want to make sure you see this. Okay. Oh, yikes. Okay. And again, you can just speed through this. Sorry, but I'm kind of late and I want to make sure I get this up for you, the kiddos. 3. Okay, they have to have a control group. And an experimental group. And they did. Okay, because group, that one. This one. Group. Okay, sorry, we have to do the handwriting thing. Group. All right. Okay, let's move this one here so it doesn't be confusing. Let's move this one. This. There. All right. Then. And this one, in this case, we did have an experimental and control group because if you remember, your control group was placebo group and the medication group, the one with which was A and placebo was B. Okay, so so it had that, and it also has to have some constant variables. Okay. Okay, and one hypothesis. In other words, they were only testing one thing at a time. Okay. Now this experiment had all those components, so then that means it is valid. Valid. Because it had all those components. Sorry, I have to do this way. Valid. So it is valid, a valid experiment. So it's a lot of little work, but it's only two problems if they were working with a buddy. And it takes some practice. They can share these answers. They can message each other, provided that they're the person in the group. If the group member does not give them their information or their answers, the part that they were supposed to do, then those people do not get credit. They get credit. Okay, so this is just some cooperation work here that they can get used to the technology and help each other out to review this. I will be posting the answers on Tuesday, okay, or probably Monday. But they should have most of their work done by Tuesday. So Tuesday after school, I'll post up the answers. And we'll probably review a little bit more of these on Monday and Tuesday when they come in to practice a little. I hope this was helpful.